So my name is Jeannie Falk Jones. So I'm the multi-county agronomist with K-State Research and Extension. I serve Wallace, Sherman, and Cheyenne counties in Northwest Kansas. And we're welcoming you to our virtual crop talk series. So this is a webinar series that when a group of extension agents all together were talking about winter programming, we were really trying to decide what the step was for getting information to everyone who couldn't be on, who we can't be in person to do this. So that's why we ended up with this virtual webinar series for Crop Talk. We're trying to address some of the hot topics that we were getting questions on from our growers. So we're gonna just jump in. Here's our Crop Talk team. You might have seen them on our credits as we were rolling around at the beginning. And so we have an effort of many extension agents in Northwest and North Central Kansas. And we've been working really close with several of our state specialists and regional specialists on getting programming directly to you guys to answer your questions. Okay, so there's a couple of ways you guys can make this very interactive today. And one of those is asking a question. Okay, so and you're looking at your Zoom screen, you'll see down here at the bottom, there is a Q&A section and a chat function. Okay, so anything that is subject matter related that you would like to have questions specifically for Dorivar on something that he's talking about, put those in the Q&A box. That helps us track those questions so we make sure that everyone's questions get answered. Now, if you have a technical question, other things that are not working well, you can't hear, can't see something, put that in the chat function. And that goes to all of the extension agents that are on here on the backside to help you get some of those technical things figured out. The other thing is, if you're watching live on YouTube, you can type a question in the comment box. You will have to have an account created in order to do that. Or if it's just easier, just send me an email and I'll get it answered and we'll get your question right into our speakers. So, okay. One other thing we're going to do is called Poll Everywhere. So this is a way that everybody can answer questions as we move through the presentation. This will kind of help direct how certain parts of the presentation go. It's no different than sitting in a room and asking questions of the speakers we're going through things. And so you can give your responses to some of the questions. What you need to do, you can either open the web browser and do pollev.com/KSU, and that will open up the response function. You can also text in your question or text in your answer. And so what you need to do is over here in your to box, where you would typically type somebody's name or number, put the numbers 22333. And that is the 2, so that gets you into Poll Everywhere. And then where you would typically put your message, type KSU, and that will bring you right into the Poll Everywhere system. That basically gets you logged in, and then you'll be able to vote on these questions as we move throughout the presentation. So we're just going to dive right in so everybody has a chance to use Poll Everywhere to see if it's working. So, okay, here is our first question. Do you guys have snow on the ground right now? Oh, shoot, I forgot to clear out our answers from yesterday. Well, you can see everyone's answers from yesterday, and this should be live. So we should be getting answers coming in here as you guys are voting. There we go. We see some no snow at all is increasing in the amounts of what everybody's seeing. You know, after those really warm temperatures, at least that we had in Colby yesterday, the amount of snow that we have on the ground is really decreasing. So what you can see, this function here allows us to see automatically what you guys' responses are, and that will kind of help direct some of the presentations that we're doing. So, okay, everybody's getting logged in and getting answers here. Good deal. All right, so we're going to go ahead and move right forward. If you are needing CCA credits, what I'm going to ask you to do is to please email me at the beginning and the end of the session. Basically, logging in at the beginning lets me know that you are here at the beginning, and sending the email at the end allows me to know that you have logged out. No different than if we were sitting in a room and you would sign in and sign out. Please put your name and your CCA number in the subject line. That way I have all of that information, so it's easy to get our list together to move forward on that. Okay, I think with that, Chris, do you want to go from there?
Sure. We'll go ahead and jump into things. And thanks, Jeannie, for covering all of that. Again, if you have questions, make sure you plug those into the Q&A box down here at the bottom, at least on the Zoom side of things, or on the YouTube side if you are following along on YouTube. We may be having a couple technical glitches on the YouTube side, but we're going to try to get through those and get them up and running. So we're going to go ahead, and I'd like to introduce Dr. Dorivar Ruiz Diaz. He is going to touch on the north central focus today of the soil fertility questions from the growers from the survey. Dr. Ruiz Diaz's program in soil fertility and nutrient management emphasizes applied field experiments to develop efficient, cost-effective, and environmentally sound nutrient management practices for agronomic crop production in Kansas. Areas of interest for Dorivar include the efficient use of fertilizers, soil test interpretations and fertilizer recommendations, land application of manure, biosolids, with emphasis on crop available nitrogen. He also assesses environmental risks associated with nutrient management and tillage. Quite a few of you have probably been on several programs that Dorivar has been involved with over the years, so we appreciate him joining us today. So turn it over to Dorivar.
Okay, good morning, everyone, and thank you for joining us today again for the second session of Soil Fertility. Again, like Chris mentioned, we developed some of these topics based on feedback from all of you. We got a lot of good questions and ideas, so we really want to keep these topics based on essentially based on questions, which is what we wanted to do. And again, we split the sessions yesterday, focus a little bit more on the questions we got from the Northwest part. And today we'll focus a little bit more on what we got from the North Central and Central part of the state. Again, just to remind everybody, as you have any questions related to what we're talking about today or any other soil fertility questions, please put it in the chat or in the questions section in Zoom. We'll make sure and leave enough time at the end. That's the idea really with this webinar, is to try and get a little bit more of the questions from the group. So please don't hesitate to do that as we are moving forward in the presentation. Okay, so today we'll talk about some of these questions that we got again from the survey, and we basically group some of these in different topics. One of the questions we got was about soil samples and when to collect those, and we'll touch briefly on that. A lot of questions on sorghum fertility, especially for top yields, and I think there's obviously a lot of interest on sorghum coming this season, good grain prices and so on, and I think there's potential there for sure. And then several questions on pH, so we'll spend some time on this, not just what's happening for in terms of pH in no-till systems, but also target pH and where that benefit in terms of yield potential and return to investment. Also, a lot of questions on sulfur, and this is becoming, of course, more of an issue for us in Kansas, and so we do have some recent data that we'll share with you as well today. Also, potassium, we'll just touch a little bit on this, specifically on high testing, and potassium, of course, is a limiting factor, especially in the east part of the state, where we do tend to have lower soil testing potassium. But there's also a lot of questions about availability of that potassium and whether or not we need to be thinking about potassium application. So we did have some studies on this last year, and I'll share some of that with you as well. Okay, so to go ahead and start with the soil samples, and we do have a lot of data and comparisons of different nutrients for this particular topic, but I just wanted to simply put this in a couple main categories: immobile nutrients and then the mobile nutrients. And mobile nutrients will be obviously your nitrogen, nitrate, nitrogen, sulfur, and chloride. And then the immobile nutrients, pK, zinc, pH, which is typically the main ones that we tend to look in surface samples, 0 to 6 inches is typically what we'll be collecting these nutrients. And now in the mobile nutrients, obviously you want to look at profiles. So typically the recommendation there will be ideally up to 24-inch sampling depth. So it's a little bit different situation for these two groups. And in the first case, in the case of immobile nutrients, we typically tend to have more flexibility in terms of time to collect those samples. Oftentimes we tend to find times of the year where obviously we don't have any crops growing, a little bit slower time. And so after harvest in the fall or in the spring usually tends to be the most popular time for sampling. And again, that's appropriate. So again, we do have flexibility. The key here is obviously we want to be consistent, especially as we're developing history for those fields. Now, one thing that we saw last year, and I think maybe some of the questions came from that, last year we have a dry conditions in late summer, early fall, and that was a challenge. And Ken, I think in at least some of the data that I see, there was some effect on some nutrients and also on pH. And so some nutrients like potassium in particular, and also at some level, phosphorus can be affected by very dry conditions. And so I think we saw some of that last year, very dry conditions, soil samples that were collected. We didn't have that cycling back of nutrients in the case of potassium. We also tend to have a little bit of salt accumulation near the surface when we have dry soils, and that usually tends to drive that pH a little bit lower. So keep that in mind if you're looking at some of your soil test results from last fall, and you're seeing some numbers that may be a little bit lower than historical values. Keep that in mind, that it's possible that we are seeing just the effect of that dry conditions last year. Now switching to the mobile nutrients and focusing specifically on nitrogen and sulfur, one of the key factors here is that nitrogen and sulfur, they are very similar in the sense that they are basically affected by microbial activity and mineralization. And so this is a key point. Because essentially once you have microbial activity and a lot of mineralization going on, obviously it's going to be affecting these two nutrients. So what we try to do with these nutrients is look at residual values, basically what's left from the previous crop and whether that we can account that for the next crop. So that's really the purpose of this sampling. And so keep that in mind. And so that means basically we want to collect those samples before spring warm up, okay? Once you have some of that microbial activity kicking in the spring, obviously we're going to have some accumulation, and then we are confounding the effect of organic matter supply combined basically with what's in the profile. So we want to keep those separate. So typically, again, late fall, winter months, early spring are good times for some of these profile nutrients. Now, one of the things I want to emphasize, and I always get this question is, we really want to avoid any sampling shortly after fertilizer application. And this is often a challenge, especially with nitrogen. Perhaps we already apply some nitrogen to the wheat crop, and we want to go and collect more samples before top dressing. And that's a little bit difficult to interpret that results, because remember, we are really analyzing nitrate. And so if you're putting urea, for example, a lot of that will be primarily in the ammonium form. So you're not capturing that nitrogen fraction. So it's very difficult to interpret that results if we are collecting samples after fertilizer application. Same thing with phosphorus and other nutrients, because obviously we do have a peak in available soluble nutrients that is not really reflecting that soil test. So again, a few key things, but this is the way I will definitely approach sampling time and look at those two different group of nutrients and keep that in mind. Okay, so we'll use the survey just to start here. I wanted to spend a little bit more time on sorghum again, and so we got a lot of questions on this. So I wanted to see what you guys see in terms of yields and kind of your average. There's a lot of questions about top yields. Can we push yields much higher in sorghum? And so just to get an idea of this group in particular, what you guys are seeing. Okay. I see most of them fall in between that, 90 to 100 bushel, 150 bushel category. Okay. I'm glad I don't see very many of any 50 bushel sorghum, which is good. Okay, I don't see any 150 yields above 150 bushel. Okay, so this is good. This gives us again an idea of this group, what you guys are seeing, and what kind of range are typically the sorghum yields. Very clearly, again, over in that range of 90 to 150 bushel yield range is pretty popular, pretty common, I guess, in this group. Okay, so we'll move on. I think this is, there's one, 150 bushel, which is actually last year, 2020, that was, I hear a lot of, cases where, 150, 170 bushel sorghum. So we are getting there. We are getting at those yield levels. And so that's something to keep in mind. Okay, so we'll move on and just wanted to emphasize and start with this basically. What do we need and what's typically the most limiting factors for sorghum in our environment? And I will follow kind of this list in this order, more or less. Nitrogen, definitely still on top. That will be always the most limiting factor. So think about that. Rate is one component, but also placement of that nitrogen, timing of that nitrogen. We're not going to have time to talk about all of that today. But again, things that we know about nitrogen and how to manage efficiently pretty much apply to sorghum as well, just like corn. And so keep that in mind. Obviously, phosphorus, we manage that based on soil tests. pH could be an issue, especially those of you who are maybe more in the south central part of the state, lower pH levels. If it is very low, we can have some significant issues there. And maybe a little bit more, we start to see some sulfur. And in terms of micronutrients, zinc and chloride typically are the ones that are more relevant for sorghum. Again, very similar to corn, if you think about that. And so just to put a little bit in perspective, and I appreciate the feedback in terms of yield range that you guys are seeing, but I just went last night and looked at our yield contest from 2020, just to see where we are in terms of yield potential for sorghum. And this is for Kansas dry land yields 170 to 190 bushel last year, sorghum. And I was very glad to see actually Kansas ranking pretty frequently in the top 3 in terms of yields among at the national level. So anyways, again, this is just give us a reference. I think you also give us an indication that the genetics is there, the potential is there. And so we obviously have many factors here in terms of management. Fertility is one component, which we basically we're gonna touch today. But again, there's potential. Unfortunately, also we have to be realistic. Where are we putting this sorghum? Is there really a real potential to reach those, or it is really a little bit more marginal fields where maybe that yield potential is not necessarily high? And so those are things that we need to keep in mind. But then going back to those yield levels and what are going to be the nitrogen and P demands compared to corn, actually will tend to be very similar in terms of demands that we'll see in corn as well. Okay, so keep that in mind in terms of nutrient uptake by sorghum, especially nitrogen, P and K. Those are just about the same as corn. Okay, and so that's one thing to keep in mind. Like I say, we always tend to be a little bit. Sorghum is a very flexible crop. It usually tends to be more tolerant to management issues and soils and so on. But at the same time, also the nutrient demands will be high for those high yield environments. And so quickly, just to look at nitrogen here, wanted to put basically as an example, this is data we collected over the years. Is basically we're looking at yields, sorghum yields, and total nitrogen uptake in the plant. Okay, so this is basically the total nitrogen in the biomass, in the grain, how much nitrogen you need, and relate that to yields. Okay, in bushels. And so obviously there's noise there. This is raw data. And so I suspected to see noise, but very, very clear trend there. And so if you look at just a scenario here. If we're getting 150 bushel or expecting 150 bushel yield sorghum, that will need somewhere around 230 pounds of nitrogen total uptake. Okay, and so that's sounds like a lot, right? But again, remember, this is the total nitrogen needs. Obviously, a lot of that's coming from the soil, and so we can go through that quickly here just to put a little bit in perspective. And I use some default numbers. This tends to be kind of a maybe a little bit on the low side for many of you. If you have an organic matter level of about 2%, that will give us about 40 pounds of nitrogen. Okay. Previous crops, assuming it's soybeans, that will another 40 pounds. And profile nitrogen, which is about the minimum default. If you don't have any values, we usually say you have at least 30 pounds. Okay, so right there, that's kind of the minimum I will expect to see from the soil in most cases. So right there, you have about 110 pounds of nitrogen from the soil. So again, a quick calculation there. That means we'll need somewhere around 120 pounds of nitrogen applied with fertilizer to meet the demands of 150 bushel sorghum. That's pretty much the same that you will get also for corn. So that relationship is very similar. In other words, we're talking about those higher yield environments. We do have that requirements in terms of nutrient that we have to meet. Again, very similar to corn. Other things in terms of sorghum, one thing that we've done a lot, this is average of 16 locations, all pretty much mostly in the north central and central part of the state in terms of chloride. We do tend to see some good responses there. Usually about 20 pounds is all we need. But again, we'll talk a little bit more about potassium later, but keep this in mind. We do tend to see some consistent response to chloride in sorghum. What about zinc? This is another one that I mentioned. Similar to corn, also very, is one of the crops that will tend to respond the most to zinc application. And this is just a half pound of 2x2 zinc apply. Soil test zinc about 0.6, okay? So it is deficient. Again, we tend to see that yield response to zinc application, in this case, with the starter fertilizer. And so again, also a crop that can respond to zinc, but again, pretty much based on soil test. So we need to watch that very closely. Okay, so we'll switch to pH and specifically no-till pH. This is, many of you have seen this before. This is data from actually from Mitchell County that we collected a couple locations looking at no-till and pH stratification. And so this is the range of pH here, sampling depths, much lower pH near the surface. And obviously our soils will tend to be higher pH in the profile. That's the nature of our soils, especially in the central and western part of the state. Now, what about aluminum? We do start to see some aluminum, especially near the surface. Okay, so that's one thing that we want to watch very closely. Obviously, with pH, low pH, aluminum is really the main problem that we want to pay attention to. And so we did some lime rates, and this is no-till, so all surface apply. Okay, so we are not incorporating any of these. And so we have 3 rates: half ton, 1 ton, and 3 tons of lime. This was pale lime, which was easier for us to apply and have access to that. And so in terms of increasing pH, we saw basically roughly about 1 unit increase with the 1 ton and close to 2 units increase with the 3 ton rate. So if you think about the pH where we are here, with the 1 unit increase, we were getting to about 6 or close to 7, actually, with the 1 and 3 ton of lime application. But again, so this is, this is in the profile. Where is that change in pH is happening? Primarily in the upper 3 inches. Okay, so we are not incorporating that lime, leaving the surface. We're really affecting the pH pretty much in the upper 3 inches. So this is pretty important, which again, for the conditions we have in no-till, again, where we have the problem near the surface, obviously that's pretty much all we need to worry about. So I think this is pretty much solving the problem of that low pH in the upper 3 inch or so. Okay, now what about yields? And that's the main question. We followed this over 3 years, rotation of wheat, corn, and soybean in that order. So the lime was applied in the summer, pretty much before wheat. we didn't see really any yield response there. In corn, we saw a small increase pretty much with a half ton. And so that pretty much captured that yield there. And soybean tends to be more sensitive. And so we needed about 1 ton to really capture the full yield potential there. Still very small yield increases. And so that's one of the things that it's a little bit of a question, right? And the economics is something to keep in mind. We have to be thinking about this a little bit differently, especially looking at these small increases. And so that was one of the main things. We saw basically a small increase in yields, but the economics of lime in general, I think we have to keep in mind that this is really a multi-year management. And so when is going to be the next time you need to go back and apply lime at these fields? I would say at least 8 to 10 years, more likely in most of our medium fine texture soils. And so again, it's really multiple years and multiple crops. And so that economics a little bit different from that standpoint. In no-till, we see that, the upper 3-inch is really where we are affecting pH. So we need to keep that in mind also for application rates. And so if you think you have some low pH problems, I will strongly recommend going back and collecting 0 to 3 inches and develop recommendations based on that, because again, that's all we are affecting really with lime application on the surface. And so there are other factors, what happened to herbicide efficacy in no-till systems, and those are, obviously we didn't look at any of that. Also, we did look at things like microbial population and activity with more, in no-till, higher organic matter and soil health. Obviously, optimum pH is also a factor that can affect microbial activity. And we were actually able to measure some of these. We did work with Chuck Rice or soil microbiologists on this, and we did saw some activity from pH and lime application on microbial activity. Obviously, the main factor typically is organic matter. Okay, so higher organic matter obviously is going to be the main factor for microbial activity in general in the soil. There's also the question of physical properties with the calcium application, which is something that we didn't evaluate, but it's a valid point also. Can that calcium maybe help with structure and infiltration? And those are obviously potential benefits from calcium application. The one question specifically we got in the survey, and I thought that was a very good point, is, okay, so what is that target pH where we need to be to get close to 100% of yield potential? And the question, the comment in the survey said that we probably need to be to about 6.8, maybe closer to 7. And most of the data we see in Kansas is that we don't need necessarily to be to that level of pH. I think we capture most of the yield and pretty close, like in this example, pretty close to 100% of yield potential when you get to about 6.4, 6.5, okay? And so most situations, typically we wanna keep at least that range of 6 to 6.4. Economically, in my opinion, there's no need to go higher than 6.4. Of course, if you're thinking about long-term, it makes sense. If you don't want to come back, wait, obviously going to take longer. If we're going to 6.6 or 6.8, it's going to take longer for that pH to come back down. So that's something to keep in mind as well. But in the short and medium term, there's really not going to be any benefit in terms of going above 6.4. Okay. One of the things also that I want to emphasize is that we see huge variability in pH in the field. And a lot of times when we start to see this problem is really when somebody's doing grid sampling, and suddenly we start to see some of these really low pH areas, things that we didn't notice before, even in our uniform soil. So I think that's something to keep in mind. I think we do see a lot of that situation. And so a lot of times we'll have to be variable rate application to really make sense and capture any potential benefit and return to investment. Okay, so switching quickly to sulfur. This is data from one of my students, Chris Weber, working on this. We have 24 locations the last couple years, different, pretty much across the state. And so I just look at couple locations, contrasting sites, where we do see some differences. And one of the things we evaluated was source of sulfur before planting in wheat. Okay, so this is 10 pounds of sulfur before drilling in the fall. We have ammonium sulfate, elemental sulfur, and we also included MESC, which is essentially 50% sulfate and 50% elemental sulfur. So the elemental sulfur, we tend to see a little bit of a lower yields in some cases, not all the cases. And I would think from that 24 locations, maybe there was 4 or 5 locations where we saw these. Most situations, again, really not a big difference. And so keep this in mind. One of the challenges with elemental sulfur is that we do need time for that sulfur to oxidize and become available. So drier environments, obviously in central and western Kansas, winter months, we don't get a lot of precipitation, but also temperature, of course, is low. So potential for oxidation tends to be much lower. So in this kind of situation, fall apply pre-plant for wheat, elemental sulfur may not be the best option. This is black leaf, the same locations, and so just kind of showing similar trends. Again, some of these were not statistically significant, but we do see some trends in mean values. And so again, in terms of sources for sulfur, dry environments and low temperature obviously will slow down that oxidation. This is a microbial driven process, so we have to keep that in mind. However, I don't want to also indicate that elemental sulfur is not a good option. If we're thinking about using elemental sulfur in the long term and we are doing regular application of elemental sulfur, actually works pretty well, especially because it's providing some residual sulfur over time. And I see this in many cases, many guys who are doing applications of elemental sulfur regularly, small amounts, is basically providing that supply of sulfur pretty regularly. So it's just a matter of what kind of system we have, what kind of program we have for managing sulfur. The other thing too is that we are seeing a lot of developments in terms of fertilizer technology. And I know for sure there are some new fertilizers looking at smaller particle size for elemental sulfur, and those are actually oxidizing much faster. So again, keep that in mind as well. Elemental sulfur, I think it has a place and actually could be even better in some of those soils that maybe has potential for leaching and so on, especially for corn. So again, it's just a matter of where we are putting some of these different sources. Rescue application of sulfur in wheat. This is something that we tend to see. Last year, I saw several, many of the county agents sent some pictures as well. And it's not uncommon, you know, green up and we start to see some yellow colors. This one situation where we have that problem and basically went back and do an application and tried to basically do a rescue application. You can very clearly see the plots where we applied the sulfur. This 10 days after application. We did get some rain in this case, of course, so that's helping to incorporate that sulfur and make it available. We have a few different sources, and one thing that is very clear here, the ones that really provide benefit in this case was ammonium sulfate, and we also got similar with gypsum, which basically is calcium sulfate. So we need to have sulfate form if we have this kind of situation. Elemental sulfur in this case, we didn't see the benefit, again, because we don't have enough time for that to break down and be available. And in this case, obviously, we need that sulfur immediately. Okay. Sampling, and this is one thing that I like to show very often. This is sampling depths and looking at sulfur in different sampling depths. And one thing that's very clear is that oftentimes we will not see a lot of sulfur in the upper 6 or 8 inches, okay? But that doesn't mean we don't have any sulfur in the profile, especially if we have some clay layers, we tend to have some accumulation of sulfur there. So essentially, again, the message here is that we need to be thinking about sulfur in a profile sampling approach. And again, if we're doing, of course, a nitrogen sampling, it's a good time to also go ahead and request a sulfur test with that kind of samples. There are some challenges though with soil test sulfur, and I'm the first one to recognize that. And one of the reasons for that challenge is because, again, like I mentioned earlier, there's a lot of influence of organic matter, mineralization, and release of sulfur from organic matter. And so we need to keep that in mind. And so sometimes we need to think about also other factors, especially things like organic matter and soil texture. And some soils are going to be more sandy soils, low organic matter. That factor alone, I think, will be indicative of potential sulfur response. And again, this profile sulfur test may not necessarily add too much more on that to that information. Again, it's a mobile nutrient, so really we need to look at profile samples, and I see this very often. 0 to 6 inch sampling that was collected, sulfur analysis on those. And I usually will not feel comfortable doing any recommendations on sulfur based on 0 to 6 inches. I just don't think we have enough information to basically tell us anything about sulfur in the soil. And of course, again, there's a lot of these mineralization rates that's sometimes difficult to estimate. And usually we tend to see most of the issues early in the spring, obviously in winter wheat, but also in corn. And a lot of this is also related to more shallow roots. And oftentimes we tend to see some of those crops maybe grow out of it, especially we do have some sulfur in their profile. So again, a little bit different compared to other nutrients and some things we need to keep in mind here. Okay, this is from the last couple of years in corn, just looking at multiple locations, and we have other treatments here, but just wanted to include UAN, 180 pounds of nitrogen, and 50 pounds of sulfur applied with as a thiosulfate. Different locations. We tried to find some of the, obviously Scandia, Belleville, those are fine texture soils, but then Rossville, Ashland, more of a coarse texture soil. We try to find those potentially responsive sites. We do see a yield, average yield difference here for Scandia, Ashland, and Rossville. We didn't see anything for the Belleville and Rossville second location we did. And so again, a lot of this tends to be also based on history, soil types, organic matter. Those tend to be kind of the key factors as well. How much we need? Not a lot. Again, we have some higher rates in our study, but typically you tend to capture most of the yield potential with 15 to 20 pounds of sulfur, okay? Okay, so we're getting close here to finishing. The last thing I wanted to talk about is potassium fertilizer application, and especially in high testing K. We know that potassium is a challenge as we go east, and especially in the southeast part of the state, soil test K can be pretty low. And so that's basically a regular management, fertility management for potassium. However, in the central and western part of the state, we tend to have usually pretty high levels of K. This is one example from last year in soybeans, 364 part per million soil test K. And so the question is, what happened to this even high testing K, though we still need to apply potassium, and thinking about the demands of the crop, especially soybean and corn, and whether or not we are supplying enough potassium during the growing season. And I think that's a valid question, because potassium uptake happens fairly quickly. And if you look at those graphs for corn, it happens even faster than nitrogen in many cases. And so I think it's a valid question. But we did this last year. This is for soybean. We have a control. Basically, we know potassium application at 50 pounds incorporated before planting, 100 pounds of K. And then we also have 80 pounds of phosphorus. In this case, was a little bit lower testing phosphorus. And the main benefit in this case obviously came from that phosphorus application. We really didn't see anything from the potassium application. And we did this in soybeans. Soybean tends to be one of the most responsive crops and actually high demands for potassium per bushel. And so that's one of the reasons we started with soybeans. But again, essentially the message here is that with those high testing, we are not really seeing that additional benefit from K application. And again, this is soybean. Critical values that we are using right now is 130 part per million. And so I think we are okay there. I think as long as we are above that value, we are not really seeing any yield benefits. And so that's something to keep in mind. I think there are some situations, and I know some states actually have higher critical values, and I think there are some situations we probably need to keep a little bit higher. But again, for most of our soils, central and western Kansas, always going to be, 200, 300 part per million or higher is not going to be uncommon. And so soybean is a big user of K per bushel. That's something to keep in mind. And as we are growing more soybean in the central part of the state in particular, it is something to keep an eye on, because obviously we are removing quite a bit of K, especially with soybeans in the rotation. And so that's something that I think is something to keep in mind. We do have plenty of K in most cases, but obviously that will tend to go down over time. And some of the more sandier soils, for example, those will be the first one that may need to some K in some situations. One thing that we are also need to keep in mind is that typically dry potassium KCl, we are putting essentially half of that is going to be, about half of that was going to be chloride. So we're putting chloride with that fertilizer. And obviously we do know that, corn, sorghum, and wheat is going to be responsive to chloride application. So a lot of that yield response that we are seeing in some situations could be coming from chloride application. The other thing also that I want to emphasize for potassium is that there could be other factors affecting K uptake, okay? Root growth in general, moisture or lack of moisture. In many cases, we have dry conditions for short times that can be affecting K uptake significantly. Compaction issues, all of those are going to be factors. So oftentimes I tend to see these. We do see some K issues, but you go and soil test, and we are seeing 300 plus part per million soil test K. But looking closer, we see that maybe compaction was a problem there affecting root growth. So that's one thing that we need to watch very closely in some of those situations. And I would like to stop there and see what we have in terms of questions. I think we do have plenty of time for questions.
Thank you, Dorivar.
Yep, I was going to say, we do have plenty of time for questions. If we want to turn it over to, I was going to say, we can start on the Zoom side. Clint, I think there were a couple that popped up there.
Yeah. Just in the Q&A and kind of right towards the end there, Dorivar, should we be applying more potassium in corn?
Yes, and the soil test, what I showed there, the critical value, 130 part per million, is still the value that I think we need to watch very closely. Higher for corn, I will say not necessarily, but again, keep in mind the removal rates that we are seeing. Soybean tends to remove quite a bit, especially with higher yieldings. And so basically we have to monitor that soil test level. In terms of potential response from corn, like I say, I think I would expect to see more response just because of that benefit of chloride application also that we tend to see from potassium fertilizer. And so again, in corn, in sorghum, in wheat, we'll tend to see that benefit. And so again, that's another component basically from potassium. The other thing that I mentioned earlier from potassium, from corn and potassium uptake, is that it happens fairly quickly. And I think that's one of the concerns that I see from many people, is that are we meeting the demands of that rapid K uptake during the growing season? And like I say, I think that's a valid point. But again, for most of our soils in central and western Kansas, I don't see that an issue. Now, if we're going eastern Kansas and those, heavier clays and that kind of situation, that could be different, okay? The release of K in that kind of situation would be different. So we need to keep that in mind. So again, central western Kansas, probably not so much.
Also, not on potassium, but shifting gears back to sulfur. I had a question about, have you seen any studies on fertility and sorghum standability?
Yes, sorghum standability and fertility. That's a very good point. I didn't show anything on that, but there's actually, and that's actually tied pretty well to the potassium topic. Chloride and potassium nutrition in sorghum could be very relevant for sorghum standability. And we've seen there's some good data in Southeast Kansas from Dan Sweeney that shows that interaction. And so again, there's specifically K and chloride could be key factors for sorghum standability when it comes to fertility. So that's something I will watch very closely. There's definitely an interaction there. And so again, in general, just good nutrition and especially chloride and potassium will be beneficial there for sorghum standability.
Thanks, Dorivar. Maybe we can shift gears to YouTube because I know there's some questions there.
Hey, alrighty. My name is Sandra Wick. I'm the crop production agent with the Post Rock Extension District. The first question, Dorivar, that came in, is it common to find aluminum toxicity effects in soils in north central Kansas?
That's a very good point. I haven't really seen any issues of aluminum toxicity problems in north central Kansas, but I have to emphasize one thing here is that I'm only looking at no-till, long-term no-till fields. And what is special about long-term no-till fields is that we tend to have much higher organic matter near the surface, okay? And so near the surface is where we see the low pH, but it's also where we are seeing the higher organic matter content. So organic matter by itself is gonna be something that's gonna help to mitigate any aluminum problems. And so we do have a little bit of interaction there, and I don't think we understand that very well, but I think the overall benefit of higher organic matter is basically helping to mitigate any potential aluminum problems. And so we tend to see more of the aluminum issues in more of those sandier soils, low organic matter soils. That's where we tend to see very often the aluminum toxicity problems.
All right, and I had another question come in on YouTube. When it comes to soil health and deeper layers of soil, is it common to use agricultural gypsum to improve the roots development system?
Yes, this is a very good question. There's actually a lot of work that came from no-till production in South America, for example, looking at gypsum application for root development in the profile. And there's some good data that shows the benefit there. One thing that I want to emphasize in our case may be a little different because, again, we do have plenty of calcium typically as we go deeper in our soils. We don't have a lot of data, we don't have any data that I know of in Kansas looking at that gypsum in particular, but again, central and western Kansas may not be the case for gypsum. Now, as we go in eastern part of the state, where we do have some cases of acidic subsoils in southeast, for example, that's maybe a place where we can see more benefit of gypsum application. One of the things I mentioned earlier for calcium, near the surface and infiltration, that's also one thing that it's a little bit difficult to measure, you know, some of the physical properties and improving infiltration and so on, but obviously calcium is helpful. We know that. And so it's just a little more difficult to measure that.
I'll turn it back over to Clint, and I think there's a few more questions on Zoom.
Thanks, Sandra. Dorivar, got a question about, and this might be a difficult one, but approximately how much sulfur do we get from the air each year?
Yes, and I don't have that in mind right now. It's been decreased significantly in recent years, and obviously with the clean air efforts that we've been doing over multiple years, and that's actually one of the main reasons why we do start to see sulfur deficiency more and more. We used to rely a lot on atmospheric deposition. I wouldn't count on that pretty much anymore at this point. Obviously, we are increasing yields as well, so we are using more sulfur, but that atmospheric deposition is just very, very little anymore. And so over time, we are using a lot of what we have in the soil, and I think in many cases, we may go many years before we need sulfur in some soils, but we're starting to see some of that develop over time. And so, again, I don't have a exact number, but I usually don't count very much anymore on that, at least for Kansas. We do have more deposition as we go northeast, but not so much in Kansas.
All right, next one about nitrogen. Applying nitrogen before tassel on corn, should we be doing it sooner than at tassel?
Yes, nitrogen in corn, later application, we've done some studies looking at split application as late as tassel. And yes, we should be doing obviously before, ideally. And a lot of this is a logistic question, you know, can we do that late application or not? Obviously, with irrigated systems, we do have the flexibility to do spoon feeding. We do see a lot of benefit in our study, especially in situations where we may have some potential losses, or if we see in higher yield potential where maybe we can go and apply additional nitrogen, we do see benefit as late as tassel. And so the key point here is that, especially with the new hybrids, I think we can go pretty late with nitrogen application and still see the benefit. We have a much bigger window. And that's a good thing, because if we're thinking about some in-season application, we can go pretty late and still get the benefit. And so that's what we saw from our corn studies on late applications.
Excellent. Next one is actually regarding chloride. How many years would a 30-pound application of potassium chloride benefit the soil?
Yes, this is a very good question. We actually done some evaluations of chloride cycling and use in corn and sorghum and wheat, and we don't remove a lot of chloride with the grain. Okay, so this is something to keep in mind. A lot of the chloride tends to basically stay in the biomass, stay in the residue, and basically cycle back to the soil. So that's a good thing. So you're specifically in the question of 30 pounds of chloride, how long that will help. And again, that will be a function of rainfall. And this is where it's a little bit difficult. Maybe as we go west, that 30 pounds of chloride could be enough for multiple years. But now if we are more in the central, you know, in the Salina corridor area, for example, we may need to do chloride applications more frequently, even for every crop, especially corn, sorghum, and wheat, because we're going to have some leaching. We do have enough rainfall to basically leach that chloride. It's a mobile nutrient. And so, again, that's the key there. As we go west, drier conditions, dry land environments, I think we can fix that issue for multiple years with 30 pounds. And I think that's where we see less response to chloride as we go west. There's a lot of work from in Tribune, in Garden City, for example, where we don't see any responses. And a lot of it is because we are seeing that chloride basically cycling back and we are not losing it with rainfall.
All right, last one here on Zoom. What is the critical soil test for sulfur?
Yes, the approach we use for sulfur in Kansas is not really necessarily a critical value, but we basically follow the same approach that we use for nitrogen. We basically look at how many pounds of sulfur we have in the profile. We also look at the total sulfur needs in the crop based on yield potential, and we basically do a balance there. Okay, so again, we are accounting for how much sulfur is coming from organic matter, how much is in the profile, just kind of like the way we did it for nitrogen in that sorghum example. So that's the approach we follow. So so then there's really not a critical value there in the approach that we have in Kansas. Now there are other systems, other recommendations where we actually some attempts to use the 0 to 6 inch sample for sulfur. And like I say, I do see very poor correlation typically for that test in particular. So that's one challenge with soil test sulfur. In general, again, it's a difficult one because we have so many of those factors like organic matter, mineralization happening in terms of sulfur. And so that's one of the challenges with soil tests. And so for us, I think the profile tends to work much better from that standpoint.
Okay, Dora, I had one more question come in on YouTube. Are phosphate rocks often used in Kansas? And is the rock solubility a problem there? I guess they're used in Brazil, and you may know that. It's common to use bay over natural rock. You probably know a lot about that.
Well, I know some, yes, rock phosphate, obviously the challenge with that is very low solubility, and that's why we typically don't use it. However, if you have lower pH, very low pH, and again, more of the high rainfall and low pH in Brazil, for example, then that could actually be beneficial to provide a little bit more of a long-term source of phosphorus. However, in our conditions, I really don't see any potential benefit there. I think the solubility is so low in our situations or conditions, lower rainfall, higher pH soils, that I don't think we'll see the level of benefit there. And so for that reason, also, I don't think we use as much.
All right. I think those are, I think we had one more, Clint, pop up in the chat.
Where would you be able to locate all the fertilizer of potassium and phosphorus before planting for all the needs in an irrigation system? Is that possible?
Yes, and we did talk a little bit about that yesterday with the fertilizer placement in corn irrigated systems. And I know many producers that basically do 100% of their fertility with a planter. However, here the key point is really we have to keep that separation from the seed. Okay, and so salt damage will be a potential issue there. So, but if we can do something like 2x2 or using liquid dribble on the surface, of course, away from the seed, we can put 100% of the needs usually without problems. Now, when we are going to pop up in furrow, then that's where we are limited with rates. And so the answer is yes, we should be able to do that. A lot of it also goes back to logistics. Okay, you have many acres. Many people don't like to mess with fertilizer at that point, especially large amounts of fertilizer. And so that's always a challenge.
One more sneak in here, Dorivar, on Zoom. And I think you touched on this yesterday, but at what soil test level would you start to use zinc fertilizer?
Yes, our recommendation right now says 1 part per million. However, what we've been doing is that we see that really you start to see more of a consistent yield benefit once you get to about 0.7 or lower. And so I do get usually some of these cases where guys are seeing, 0.8, 0.9 part per million, and based on the economics and the system they have, I will usually say, you can probably wait, a year or two before you apply zinc. Because again, in terms of consistent yield benefit, you get 0.7 and lower, that's where we really see consistent yield benefits. But the critical value we use is 1 part per million.
All right. I think that looks like most of the questions. Oh, I had another one pop in, Clint. Nope, just somebody thanking for the info. So I think that should do, that's it for the questions that I see so far. For those that might have other questions, Dorivar did put some of his information up there on his slide. If you would like to contact him, or you can contact your local extension office and we can try to help you out as well, or get you in contact with Dorivar if it's something that we aren't able to handle, or it's something directly for him. He'll be able to take care of it. So we do again want to thank Dorivar for all of his time the last couple of days been on with us and presenting his information. So, and that brings us to the next step before everybody logs off. Clint has posted up the link for our survey or our evaluation. If you would please click on that link. Here on Zoom, you can see that in the chat box, or on YouTube, Sandra has posted that as well. That is an evaluation that is very important to us. If you can please use that link to complete it's a very short evaluation. That information we utilize and take a look at as far as, the handling of this programming. This is kind of a different approach that we have done this winter with our programming efforts, as Jeannie's mentioned in the intro. So this is a very important piece of information that we're going to use for a lot of our programming as far as going forward. So we'll look at that information as well as some of your other demographic information that is very important to how we do our reporting for all of our programming and efforts here. So with that, if you could please, again, fill out that evaluation that is in the chat box on whichever platform you're viewing, please do so. You can also see on the screen, don't forget next week, join us for our next 2 sessions coming up on Tuesday and Wednesday, weed management and the pesky Palmer amaranth. We do have our 2 presenters next week, Sarah Lancaster and Vipin Kumar, are going to be with us and discussing that information. Tuesday, we're going to hit on mostly the Northwest, kind of that focus for Northwest area. Wednesday will be the North Central. It's going to be in this, use your same link, same time, and that will get you into that presentation as well. So I want to thank everybody for joining us. And again, if you can fill out that evaluation, that would be fantastic. If you are getting CCA credits and you need to sign out, please see the email jfalkjones@ksu.edu. Send that email to Jeannie that you are signing out to receive your CCA credit. And with no other questions, I believe that's going to do it for us here today. Again, thanks for joining us, and we will hopefully see everybody next week.